Welcome back folks to this new video on the serial communication using Atmega 328P microcontroller. So this microcontroller has one hardware serial port which is attached to second and third pin of port D. Let me see if I can get an image. So you can see here, so the serial port is this pin number 0 and 1 here. So pin number 0 and 1 in the Arduino Uno board. So that is again pin number 0 and 1 of port D. So pin number 0 is the receiver, pin number 1 is the transmitter. So in this video we are going to talk about the transmitter first, and in the next video we will talk about the receiver. So in order to use the serial port, we have to do certain configurations. So what are these configurations? In fact, when we are working with serial communication, the transmitter and the receiver has to agree to certain things. Number one is the baud rate. So the speed of transmission should be agreed by the both sides. So if I am setting my baud rate to a certain value in my transmitter, at the receiver they have to set it to the same baud rate. So other than the baud rate, we have to make sure that the number of stop bits that we are using in our data frame, and the parity bit and the parity bit type if we are using any parity, and the number of data bits in our frame has to be configured by the transmitter, and the receiver should know what is coming in. And the typical USART or typical serial port communication connection looks like this, which is shown in the image. So transmitter pin of one has to be connected to the receiver pin of the other, and the receiver pin of that has to be connected to the transmitter pin of the other, and the ground should be connected. So if you have this configuration, we can have serial transmit and receive mode both. So if you only need the receiver for a particular device, you can only connect the receiver to the transmitter of the other device, and if you need the transmitter only, you can connect the transmitter to the receiver of the other device. You don't have to connect both if you are only using one, but there's no harm in connecting both. Now we will look into what are the registers that we have to set to configure the UART or the serial communication. So serial communication we call UART communication as well, that is universal asynchronous receiver and transmitter. In this particular device we call it USART, that is universal synchronous asynchronous transmitter and receiver. So what is this synchronous and asynchronous modes? So typically this serial communication is asynchronous. That means there is no clock connection between the transmitter and the receiver. They are working independently. But if we connect a clock from the transmitter to the receiver, the communication becomes a synchronous communication. So in this particular device we have this synchronous and asynchronous modes both. So either way we have to set the baud rate. So how are we going to set the baud rate in this particular device? That is using this UBRR0L register. So UBRR0L and UBRR0H register values has to be calculated using this particular equation given. So this UBRR register is a 16-bit register. So in that 16-bit register, upper 8 bits are called UBRR0H and the lower 8 bits are called UBRR0L, and the value is calculated by the oscillator or the clock frequency of the microcontroller divided by 16 times the baud rate and minus 1. So again lower 8 bits is set to UBRR0L and the upper bits are set to UBRR0H. We will discuss that when we come to that. and then we have to enable the transmitter and the receiver if you are to use the transmitter and the receiver. So if we are only using the transmitter, you can only enable the transmitter. If we are only using the receiver, we can only enable the receiver. If we are using both, we have to enable both. So this is at UCSR0B register. So if we are using interrupts, we have to enable those interrupts as well, transmitter interrupt, the receiver interrupt and stuff. So in this particular example, we are not going to use them. So as long as we are not going to use them, we don't have to set them. So we only have to set the transmitter in this case. So other than those two, then we have to set number of data bits in our frame. So typically we are using 8 bits, but if you want to use 5 bits, 6 bits, 7 bits or 9 bits, that is also possible. So that is being set by this UCSZ00, UCSZ01 and UCSZ02. These two values can be configured according to this given table. So if we want to use 8-bit transmission, so we are going to use 0, 1, 1. That means 0 to UCSZ02 and 1 and 1 to these two, UCSZ01 and UCSZ00. So those are in fact two different registers, that is UCSR0B register and UCSR0C register. And if you are to choose synchronous transmission, that means if there is a common clock between the transmitter and the receiver, then we have to choose these two bits UMSCL01 and UMSCL00 bits to be 0 and 1. But we are not using a common clock, we are using the asynchronous mode. Because of that, these two should be 0 and 0, that is given in here in this table. And if we are going to use parity, whether it is even parity or odd parity, we have to set our UPM 01 and UPM 00 bits to either 10 and 11. But in this case, I'm going to disable parity. I'm not going to need parity because this is like a very simple transmission. Because of that, I'm going to set these to 0 and 0. But there's no harm in either using odd parity or even parity in your communication. But if whatever you set here has to be set at the receiver as well. And number of stop bits, so stop bits can be 1 stop bit and 2 stop bits in this particular case. So if this particular bit USB-S0 bit is 0 if we are using 1 stop bit, and that bit is 1 if we are to use 2 stop bits. So here I am using only 1 stop bit, because of that I am making this 0. So once we configure everything, then the data what is being received at the receiver will be stored at this UDR0 register. So that is a 8-bit register. So if since we are using 8-bit mode, there's no problem, we can directly copy this register value to wherever we want and get the received values. But if we are using 5 bits, 6 bits, 7 bits or 9 bits, there are different ways of doing this. So I'm not going to discuss everything. So everything is available at the datasheet. So other than that, then when we are transmitting data, right, when we are transmitting data, we have to set this UDR0 register to the whatever the values we want to transmit, and then this will automatically push this data out of our UART. So the problem is we don't know whether the bits we have already set are being transmitted or not, right? So because we will be keep on writing to this register, and this register will push the data out, but we don't know if everything has pushed out. So if everything has not yet pushed out, we should not be rewriting onto this register, because that will damage whatever is in this register which is waiting to be transmitted, right? Because of that, we have to look into this UDRE0 register in this UDRE0 bit of this UCSR0A register. So this bit is 1 if this buffer is, or this register is ready to obtain data, right? So if this bit is 0, that means this is not ready to accept data. So we have to wait until this bit becomes 1, and only when this becomes 1 we have to set data here such that this will push it out, and once this will push out, once this becomes free, this bit will be becoming 1. So in that case we have to go check this bit and set our transmit bits to this register, right? So that is how we are going to do this. So what are the operations that we are going to do? Configure the UART, right? Configure the UART, then we have to wait, configure the UART, then we have to wait until this bit becomes 1. When this bit becomes 1, we are going to set our data to this register and wait until this bit becomes 1 again to set the next set of data, right? So now we are going to do a task to transmit numbers from 0 to 9 repetitively through our serial port, right? So we will be transmitting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2. Likewise, we will be keep on transmitting. So while we are transmitting, we are going to turn an LED which is attached to port B pin 5 on throughout our operation. So for that, our flowchart would look like this. So in that, we are going to configure the UART, configure the port B pin 5 as an output port, and set that particular pin 5 to high. That means we are turning on the LED. So we are going to define a variable x which is equal to 0, and we are going to write a never ending while loop. In that while loop, we are going to transmit x mod 10. X mod 10 means what? So if x is 0, x mod 10 is 0. If x is 1, x mod 10 is 1. If x is 2, x mod 10 is 2. And if x is 10, x mod 10 is back to 0. If x is 11, x mod 10 is 1 again. So this operation will always give a value between 0 to 9, and we will keep on incrementing x. So x will keep on incrementing from 0 to 9, and when it becomes 10, again this will transmit 0, and when it becomes 11, this will transmit 1. Likewise, this will keep on transmitting from 0 to 9 over and over. So that is what our operation is. So in order to do this operation, I am going to choose my baud rate to be 9600. We can even choose 15200 if you want, but in this particular example I am going to choose my baud rate to be 9600. So if I choose my baud rate to be 9600, my UBRR register value will be clock frequency divided by 16 times the baud rate minus 1. So that is 16 million divided by 16 into 9600 minus 1. So I'm not going to write down the answers here. I can just leave it as it is. So my answer will be in this particular label, my UBRR. My UBRR is equal to this value. So in my UBRR, lower 8 bits are set to UBRR 0L and upper 8 bits are set to UBRR 0H. So I'm gonna directly extract the last 8 bits. So FF means 8 bits, last 8 bits to UBRR 0L, and then I'm going to shift my UBRR right 8 times. So my upper 8 bits will become the lower 8 bits from that, and when after doing that, then again I'm going to, this should not be AND, this should be AND. I'm going to AND with 0xFF. By doing so, I'm going to again extract the lower 8 bits which used to be the upper 8 bits of this one to UBRR 0H. So this is how I'm going to set my baud rate. So once I set the baud rate, then I'm going to select one stop bit, parity mode disable, and asynchronous mode. So these are zeros, and oh yeah, everything will be zeros here, right? That I can set by UCSR0C, everything to be 0, all these to be 0, and ending this with 1 will not change these values, right? And then I'm going to set my number of data bits. Number of data bits are set by this one 0 and these two 1 1. So how do I set this? I'm setting that by making this one to be 0 and these two to be 1. So how do I make these two to be 1? So I can either O with 0 0 0 0 0 1 1 0, right? That is one way of doing it. Same thing can be done by shifting this UCSZ01. UCSZ01 is UCSZ01 is the bit number, right? So this is in the hardware definition where you have these register names. So I'm going to shift 1, this is 2 times, right? So 1 is here, 1 means 0 0 0 0 0 0 0 1. I'm going to shift 1 2 times, 1 2 and O with this. So with that I'm going to make this bit 1, and UCSZ00 again shift, sorry, 1 shift this many times. So UCSZ00 is 1, so 1 shifted by 1 is here. So when I O these two, that this will be 0 0 0 0 0 1 1 0, right? And then I'm ORing that with this one, right? So that will give 0 0 0 0 0 1 1 0 O with UCSR0C register. So in that case these two bits will become 1 and neither of these will change. Similarly, I just want to set this bit to 1. So in order to make that bit to 1, I am going to shift 1 1 2 3 times. If I shift 1 1 2 3 times, it will be here. So that will be 0 0 0 0 1 0 0 0, and I am going to O that with UCSR0B register. In that case all these bits will remain same and this bit will become 1, right? So why am I doing this? This is to make my transmitter enable. So I'm going to enable the transmitter, set these 3 bits, sorry, set my transmit bits to be 8 bits. So I'm setting this one to 0 and these two to be 1 and 1, right? So my code will be setting the processor speed or the clock speed and setting my UBRR value. So my UBRR value I'm calculating here, right? After calculating the UBRR value, then I'm setting my UBRR value here. So UBRR0L is directly this value. This is only last 8 bits. So if I cast this to unsigned char, that is only 8 bits. So I'm setting last 8 bits of this one to UBRR0L and shifting this one 8 times and assign last 8 bits again to UBRR0H. So here by doing this, I'm setting my baud rate, and then I'm enabling the transmitter here. I'm enabling the transmitter, and here I'm setting my number of data to 8 bits. So here now I have finished configuring my UART, right? I have finished configuring. In fact, I can, if I want, I can set these bits to be 0 as well. I have not done that. UCSR0C, right? I can set these to be 0. I have not done that because by default when I start my microcontroller, these bits are 0. Because of that I am not setting this to 0, but if I want, I can do this and set those bits to 0, right? There's no problem in doing that. And then, so this is my configuration function, and at the beginning I'm using that function to configure my USART, and then I'm configuring the data direction of my port B pin 5, and I'm turning on the LED, making x equal to 0. In the never ending while loop, I'm calling my USART transmit function. So I will discuss this in a while. So in the USART transmit function, what I am doing is, right, whatever the data, which is 8-bit, unsigned char means 8-bit, whatever the data coming in, I'm gonna set to my transmit buffer. So before setting it to transmit buffer, I'm gonna wait until my UDRE0 bit becomes 1. So what does this means? This means while, right, UCSR0A and 1 shifted by UDRE0 times. That means this will make this particular value to UDRE0 bits value. How? Because when I shift 1 this many number of times, then rest of the bits will become 0. This bit will become 1 here, right? Rest is 0. So when I AND with that one, whatever in the UDRE0 position of this register will remain as it is, and rest will become 0. So when that is 0, this is logical NOT, right? This is logical NOT. So if this is 0, then not 0 means 1, right? If this is 1, not 1 means 0, right? So while this will keep on looping here if this bit is 0. Why? Because if this is 0, if this bit is 0, then by doing logical NOT it will become 1. So while 1 it will circulate here. So as soon as that bit becomes 0, sorry, that bit becomes 1, then not 1 means 0, and then while 0 it comes out of the loop and set the transmit port to my data and transmit, right? So in the USART transmit function it will get 8-bit data as my parameter and wait until this bit becomes 1 and transmit those bits, right? So inside the never ending while loop I'm going to transmit something. So what am I going to transmit? I'm going to transmit x mod 10. So what is this 0x03 plus? That means if I am displaying something in my serial monitor, so I'm going to use my serial monitor in this case, right? So I'm going to use my serial monitor in this case. I don't know, I have the sample. Yeah. So I'm going to use this transmit pin and attach it to my serial monitor. So in this serial monitor, if I am to display something, that will be displayed in ASCII, right? So if I am displaying in ASCII, if I want to transmit, if I want to display a number, let's say I want to display 5. If I want to display 5, that has to be sent as either character 5 or ASCII value hexadecimal 35, right? 35 in fact, 35 hexadecimal, because in ASCII values, so this is the ASCII table, right? This is the ASCII table. In the ASCII table, my 0 is 48. 48 means in hexadecimal that is 0x30, right? In decimal 48 means hexadecimal 0x30. So if I want to transmit 0 in ASCII, that is transmitted as 0x30, right? So now I want to transmit something, I don't know whether it is 0, 1, 2, 3 or whatever. So that particular value I have to add to 0x30 if I want to transmit that value using ASCII, right? So here I am transmitting as 0x30 plus whatever the value I want to transmit. It can be 0, it can be 1. If it is 0, I am transmitting 0x30 which correspond to 0. So in serial monitor it will be displayed as 0. If I transmit 5, then if my x mod 10 is 5, if I want to display 5, if I want to display 5, then that will be that should be transmitted as 0x35, right? 0x30 plus 5 in order to be displayed at the serial monitor as 5, right? And then I'm increasing the or incrementing the my x value, and I'm going to wait for 250 milliseconds just for sake of clarity, right? So here I'll be transmitting the value, incrementing the value, again transmitting the value, incrementing the value, wait, transmitting the value, incrementing the value, wait. Likewise I will be keep on transmitting 0 to 9 back to 0 over and over in this loop, right? So that's all. So we will go into our Proteus simulation, and first we will look into our code in Atmega Studio. So this is the same code that I have shown in the slide. So it is the same code. Let's build this project, right? So let me see if the build is successful. Yeah, build is successful. Let me see if I have the correct file. USART transmitter .hex. Okay. Now I have played. So in fact in this particular simulation I have attached the transmitter here as well, sender and receiver, which I will be using in a later example. Here I am only using this receiver, so this receiver corresponds to this receiver. So in there I'm receiving 0 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8 9 0 1 2. Likewise I keep on receiving, so this will repetitively sending 0 to 9, and I have turned on this LED as well. So this will keep on going forever unless the simulation crashes. So I'm gonna stop the simulation. We'll go on to the code. So let's say I want to display something before this. So I'm gonna go here and USART transmit. Let's say I want to display H. So I can only transmit character wise, right? So each one is a character. So here, since I want to send a number, I'm sending this using 0x30 plus something, because I don't know what is the number here. But if I know exactly what I'm going to transmit, I can just transmit it as a directly as a character. So H E L L O, right. Let's build it. Build successful, and play it and see. You can see HELLO, then 0 1 2 3 4 5 6 7 8 9. So the transmitter works. So this is not in fact a difficult task. So this is pretty simple using the transmitter only. So in the next example I will show you how to use the transmitter and the receiver at the same time. Okay, thank you.